Using GitHub Copilot in Visual Studio 2026 for a code rewrite. This video is part of the series, and if you've not seen the previous videos, you can check them out. I have previously gone in detail about what this application is about. In this section, I'll be rewriting the random numbers generator being used by the legacy application. This is going to be a practical example of trying to use Copilot on code that was not well written. The quick summary and main takeaway points from this video is that when doing a big rewrite, the developer needs to have in-depth knowledge of what the application is actually trying to achieve. In a way, the developer still has to be the domain expert and not just completely expect AI to give useful insights. Example scenarios in which a legacy application needs to be updated or rewritten by a different team. Say the original developer has left the company, or there's not enough documentation. Things can get tricky if the original code was also badly written, and only original developer knows what each little quick hack is doing. So that's the high-level takeaway of this video. Now, continuing with the rewrite of this old application, I created this a long time ago. The random number class is a core part of the system, but it lives in a separate external library. The very first simple thing would be to have the class as part of the solution. Then, looking at the original code, just wasn't well written, it's not good. The class is trying to do a lot of stuff, it's trying to be multi-purpose. So I think I was trying to have it being reused by other applications. So it's too generic, it's almost like a reusable library. In the revised version, the new version that I'm going to now create, I want to trim down on all the methods that are not being used. Copilot can answer this question, and there are only 2 methods being invoked in random numbers. Just as a side note, getting GitHub Copilot to just give me this simple basic information took a couple of minutes, roughly 3 to 5 minutes, just to answer this very basic question. Now, in practice, I would have 20, 30, however many other questions, and each of them would take Copilot about 5 minutes, 3 to 5 minutes to compute. So all of these little snippets of minutes can actually add up over like 3 to 5 hours. Again, the point here is that sometimes there's just no shortcut. If you've got code that's bad and you're confused, sometimes AI can't give you that shortcut, and maybe you might even have to go through the code, each method line by line, or each class, maybe be confused for the first few hours, and then it might eventually make sense. First task now is for Copilot to rewrite this class with only the methods that are being invoked. Okay, so this is now the new class is created in the new solution, and if I was just to have a quick check, only those 2 methods are actually there. Now, this method, getUniqueRandomNumbers, is meant to somehow store the previously generated random numbers in memory and ensure the same number is not being used. This method does need some detailed code review. So some of the issues now with this random numbers where you could be generating however many, the execution of this method is not deterministic. So meaning that if you generate 1 million unique random numbers, that's going to be significantly more intensive than, let's say, if you were just doing 1,000. So just if we were to take a step back and remind us as to why million numbers you might want to generate, if maybe I'm running a simulation for the past 10 years of how the lottery would have played out. So I might need a lot more than just maybe for the one playing session. So I'm going to need maybe 1 set of numbers for each week for the past 10 years. So that's how you can end up with like 1 million unique random numbers. Okay, now going back to the method, I'm not sure if it actually needs to be treated as an async in the same way that we treat async await. And another issue being raised by Copilot is that this method is not really thread safe, since we are using a collection, we're storing numbers into a list. So reading directly the suggestions from Copilot, random number generation is CPU bound, no input-output. Do not make pure CPU work by using async await alone. That only adds overhead. If callers may request very large counts that could block the caller's thread, provide an offload option that runs the CPU on a background thread, example task.run, and support cancellation and progress. Always offer a fast synchronous path for small requests. So now there's a big change. This is going to be a big change in how random numbers behave, and it now has an asynchronous methods. Also the fact that it can take a couple of seconds generating large numbers of random numbers. Originally I've put this class as a pure domain in the domain project. It no longer fits this concept. Instead now it has become more of a service. In very high level vague terms, it's going to be similar to how if you're calling a resource such as a database or a file system. A cancellation token is going to have to be supplied for if the operation stalls or it takes too long. So I'll move random numbers out of the domain project to infrastructure. This is done. The new class is much slimmer, more readable and focused. Now for the part where many years later as a developer who wrote this code, you're just completely lost, even if you're the one who wrote everything, every line, every method. This lottery number generator class appears to be a very important, but I'm just confused and do not know exactly what most of these methods are doing. Now, before asking Copilot, I'm already aware that AI will not be able to answer everything accurately. In some cases, it will give the impression of providing useful information, but a developer would still need to have you're still going to have to know what the system is doing in detail, not just on a high level. So now AI can also just lead me down the wrong path, mostly because this code is not well written. After spending close to about 2 hours poking around, I still don't have the in-depth understanding, because basically the code is cluttered with too many methods, making it hard to know what's important and which methods are redundant or what can be simplified. I just want to make this point that a code rewrite is not a refactoring. So my goal with this rewrite is to have more streamlined code. I don't just want to carry over refactored cluttered. So I don't just want AI or Copilot rewrite methods neatly, but they are not needed or the architecture has changed. To do a proper rewrite, I'm going to have 100% understanding of the intention behind every method. So let's give Copilot a try. And let's see if it can help me with an in-depth understanding. So on a higher level, almost like on a specification level. Okay, here's the explanation. I'm just trying to read it. I've selected to use ChatGPT 5 mini. And just as I suspected, it spits out a lot of information, but it's not necessarily useful. I still don't know if deleting some of the methods will break other parts of the code. So in this case, Copilot cannot really help me, which is fair. Now let me try another model, which is going to be Grok code, and let me ask it specifically to explain this class winning numbers permutation. And here's the explanation. And in short, this permutation data is a pre-computed set of numbers that are more realistic. Instead of every time I need a random number, I'm going to just be generating one, and it might fall outside the scope of playing the lottery. Now, this explanation is actually a lot more useful, and as a slight irony that the model that nobody's talking about at the moment, which is Grok, was able to clear my confusion. It took me 2 hours of poking around and I still didn't understand, but Grok sort of just summarized it very, very, very simply. The good thing is that Grok at the moment doesn't use any premium requests. It's actually free. So you can actually, like I was saying, you could use different models for different parts. So if you just want an explanation or a high level view, you could use the free models, and then for the actual coding and doing the rewrite, you could use the premium models. So in terms of the current state of the code, let's just take a step back and see where we are. My immediate goal is to have a baseline random numbers generator. This utility class is purely just for random numbers and not so much about playing the lottery. The generator will then be used by high-level classes that are more focused on, let's say, playing the lottery. Looking at the old implementation, everything is more or less lumped into one project or one class. I did try and make it look neat, but it's actually still spaghetti code. There's a lot going on in this one class. Some parts are pure random numbers, and other parts are making calls to the database to get historical data and past winning results. If we look at the new updated version, the goal is to have a less cluttered and more organization. There are separate projects just for the basic random numbers, which now lives in a utility project. Then the lottery numbers generation, which will need a repository to get historical data, this now lives in a separate services project. So there's no confusion, there's no lumping, so everything is actually laid out. If you're going to be calling the database, you're going to live in a services project. Okay, now for creating the tests, Copilot created this updated random numbers generator, and now I also wanted to create the tests. These will be integration tests, since it is possible to generate a large set of numbers and we have to be able to cancel the operation if it starts to take too long. I will actually prompt Copilot to create the test project, place it under the solution folder, 02 integration, then also create the integration tests, and it must not use any mocks. So I'm going to write this prompt in Word on a higher level, and here's the prompt where I instruct Copilot to follow some sort of convention. The goal is to have each public method be tested. It's going to be under its own test class ending with a should, and let's see if this can be done. I actually forgot to tell Copilot one minor important detail, which is to add a project reference to the utility class. Otherwise, there's not going to be anything to test. Okay, now, the other small issue when creating the test project, I didn't explicitly state the test project has to be in .NET 10. I just assumed Copilot would be smart enough to see the rest of the solution. All the other projects are on .NET 10, and then just also have the new project that it's adding and put it on the same version. Okay, so I've had to do the fixes quickly myself, but now looking at the tests, they're quite simple. They do pass. There's really nothing special at this stage, right? So everything is done. And for this stage of the rewrite, I've actually reached my little goal. And once again, the takeaway from this video: when using AI for understanding code that somebody else has written, or even code that you wrote yourself a while back, it's a good idea to use different models. ChatGPT 5 Mini, the free model, only gave me a high-level overview. This information is redundant when doing a rewrite, when you need to start moving code around and introducing major architectural changes. Grok was actually much better at explaining in detail what some aspects of the code are doing. I was surprised that it even explained the intent. In a way, it was almost like writing a specification. I could then completely rewrite the class, throwing away the old clutter. The other point, just the level of detail in the prompts. Because we send instructions to Copilot in a human language, it still needs to be pointed to the detailed specifics. For example, I asked ChatGPT 5 Mini to add a new test project in a solution. I didn't specify the framework version. I just sort of assumed it would figure this out by itself by looking at the other projects and just use the same version. It gets tricky to keep track of every little detail when giving high-level prompts, especially when the Copilot agent needs to do a lot of multiple actions. So those are the takeaway points for this section.